you go. So we're going to work on integration by parts here. I'm going to blow up my screen. And I put up an integral right here that until today you wouldn't know how to integrate, or you'd think you can't, because our biggest technique is U sub, and we don't have a product rule for integration. This is its best equivalent, is what we're going to do today, because you do use it when you have a product, you just can't use it for all products. So what I did to show you is I went to some computational software. I went to Wolfram Alpha. It does a lot of science and math if you just tell it what to do with words. So in physics, like if you say find work when forces, whatever, it'll do it for you. The kicker is to get the solution. Guess what you have to do? Hey. So it's not a great a sight as you think, but it does give you the final answer. So I put that on here, and we're going to try to figure out how did they get that. All right, so let's just point an arrow down there so we don't have to rewrite it. So somehow they were able to undo that product in there and come up with the answer. Let's see if their answer's right, because remember when you find antiderivative, if I derivate this guy on the right, I better get x cosine x. So I'm going to go over here and just use some Calc 1 to take this guy's derivative. I'll do it really fast. I would do first d second plus second, d first would be 1, and then the derivative of cosine is negative sine. All constants go to 0. Gone, gone. I walked myself right back to the integrand. Make sense, Joel? Yes? Are you feeling better?
Yeah.
Weren't you ill?
Not yesterday.
Well, I know that. But
Yeah.
recently. Okay. So anyway, the question is, how do you get that? Like, I can see that it works, but how do I get that? And it is with a process called integration by parts. Normally, like when I do this next year for the juniors, I'm going to say where it comes from. But not today, because I told you guys no homework. Maybe, hopefully seniors, you have a professor who will show you where it comes from. But I'm just going to put the model on here. So, and it's not going to make any sense when I write it down until we go do it. But when you integrate and you have a product in there, and we call that product U and a dv. So in my original, it was x cosine x, right? Yep. One of these we call U, maybe it's the x, or maybe it's the cosine x. The other one is what we'd call dv. So there's two functions in here, they get two names. Either x is u and cosine x dx is dv, or cosine x is u and x dx is dv. There's only two possibilities. I'll tell you how you decide. But what it always equals, once you figure out who's your u and who's your dv, and it's just going to look like a bunch of voodoo, is uv minus the integral of v du. What? That doesn't make any sense. It doesn't, because I didn't derive it for you. We're just going to use it. Are there geese out there again? No? Okay. There were geese out there yesterday. Imagine that with sophomores. There's a goose. Look at the geese. All right, anyway. Where am I? So the way in Minnesota it's easy to remember this is we say oofda, and this looks like oofda. It's pretty easy to memorize. No one in BC ever forgets it. Like if you were to ask them what's by parts, they go oofda, and they have it. But if you have a college roommate from California and you say, you use oofda, they'll be like, what are you talking about? That's a LaRue thing, not a math book thing. Now what?
People are running around.
Well, they're just having fun. And you guys aren't. Haha. No, just kidding. All right.
Wow.
So, anyway, we're going to go kind of show how this works. There's an acronym. Why isn't it turning? Oh, there we go. Too far. All right. So we're going to put that same integral up here again. One of these I told you is u. And the question is ux or is u cosine x? It's not u sub, though. It's just u is one of those things. To decide, we're going to use an acronym. And I like to call it LIATE. I've heard it called LIATE, but that doesn't sound as good. It sounds what I say. Like if I said, what'd you have for lunch today? And she said, chicken nuggets, I'd be, oh. But if she said, chicken nougates, I'd be like, oh. Now that sounds delicious, right? So, I'm going to call it the Liate. And it gives you the hierarchy of who your U can be, and I'll define what they each stand for in just a second. They're each a different type of function. But even more than how to do it is when to do it. And I usually say 90% of the time, because it's not always, but it's a really good trigger, when you see what I call incompatible functions in the integrand. I've got a polynomial paired up with a trig function. They don't go together. Neither do their derivatives or their integrals. If I see e to the x paired with cosine x, I'm like, those are two entirely different function families. An exponential function and a trig function. That triggers by parts. What they had on the BC exam this year, it was hidden in an area problem, but when they set up their integral, they ended up with this. And it was an area one. You know how when you do area, you usually end up integrating? Their by parts was hidden in an FRQ, and then it had some limits on it. But when they see this, they first try u sub, because I tell them all the time, to let u be the exponent, hoping its derivative is the rest. But its the derivative is 1/5, and I can't create an x, correct? So I have these incompatible functions. They should have known to immediately launch into by parts. So it's usually when you see those incompatible functions. So what does the L stand for? And again, this is your U choice, because there's two parts to it. Who's U? First, if you see a logarithmic function, and in calculus, it's almost always our natural log. So if you see that, that's your U. It could be ln x cubed, or ln x over 4, but you see a natural log. I stands for inverse trig. Juniors who have this next year, we're going to talk about the reason why it's in this order, but today I'm just giving you a taste for this. All right? A stands for algebraic. It's kind of right in the middle, and by algebra, I'll put some inverse trig, by the way, it's like if you see some arc sine, some arc cosine, arc tan, all that lovely stuff. Algebraic, I mean the polynomials. Like x squared plus 1. I think there's a 5x to the 6 plus 3 on one of your problems in delta math. But even be careful, because 1, 5, and constants are also algebraic or polynomials. They're 1x to the 0 and 5x to the 0. So watch out for those. Underline this guy, because you don't see it. Does that make sense? Like if we're going to be integrating the natural log of x, and you're not going to see 1 dx. You're just going to see dx, but it really is going to be the product of two incompatible functions. All right, T stands for your normal trigs. Your sines, your cosines, your tangents, all those lovely secants, that kind of thing. And lastly, E is our exponential functions. Usually the base is E, so e to the something, maybe it's e to the 2x, maybe it's a 2 to the x, but those are our last choice, all right? And to remember it, just think Liate. So, I told you the model, right? I told you the hierarchy of who gets to be the U, but you should be really confused still, because we haven't done it yet. Right? So we're going to go back to that original guy that I wolframmed, and I put the answer up there. So can you guys remind me what it was? You go back, it was x sine x plus cosine. Thank you, plus cosine x plus c. We're going to get that using all the stuff I just told you and putting it together. So we're going to go off to the side, and we're going to define our U choice based on our acronym. Is it the algebraic function or the trig function? Which one comes first in Liate? Algebraic. That gets to be my U choice. Now what I usually have you kids do is make a 2x2 array. So put the U up here, and the dv is the rest of it. It's the cosine x dx. So I'm now sitting there trying to integrate u dv technically, just so you can see it. Next up, you're going to take this guy's derivative. What's the derivative of x? 1. Yep, so du dx is 1, or du is 1 dx. Up here, I'm going to erase this. I'm going to go backwards and undo the derivative of v. So I derivate and I integrate. What's the antiderivative of cosine? Sine. Yeah, thank you guys. Perfect. Now I told you that it equals uv, right? So actually I'm going to change colors here to make it clear. If you make an array like this, you can just do a zigzag. So it's uv minus v du. This isn't in it at all. Okay? So if I were to do my uv minus v du, I would get this. X sine x, my uv. Oh hey, that's what Wolfram got. Right? And then I do minus, and then I do the integral of v times du. So it'd be sine x dx. What's the antiderivative of sine x? Negative cosine, but I'm subtracting it. Because you're the second class today, I can tell you that on the delta math, sorry, I meant to put a plus C. On the delta math, what was the only thing that was goofing them up is when they had negatives in here and then this negative. So Allison and Bethany worked on one. They both got the same answer because you guys are all going to have the same problems, so you can work with somebody. I programmed Delta to give you the same instead of random. And so they were working on it together. They got the same answer, plugged it in, and it was wrong. And they're like, what? And they both did the same thing. They had two negatives in here, but then there was a negative here, and they were thinking it out, and they used a plus. Does that make sense? So that, watch all the negatives that are going to occur here, and just kind of count them up. Like 1, 2, 3, I need to have a minus. All right, I don't need to check it because I did on the other page. Now we're going to go practice. All right. So first of all, I'm going to have you beware. Above this, right, this guy. This could have been, the one above it in blue, could have been on the AP AB test. And maybe it was. I don't know. I can't see the multiple choice. How would you have done the one in blue? It looks so similar to the one in black. Blue is, yeah, Chris, it's USA. Almost in your head, right? Who's U? X squared. Who's du? 2x dx. I'd need a 1/2 correction, right? And I'd have the rest of it. So this is really 1/2 e to the u du. 1/2 e to the x squared plus c. I'm done. I almost did it in my head. Just removing this power. Now if u is x, du is 1. I can't create a variable, right? I can create numbers, but not variables. So now it's out, and that should trigger by parts. Do you remember why, even though I only told you once? And why should by parts be an option for this one? What do you see in the integrand? Incompatible functions, right? Because in Calc 2, those of you seniors going to college or juniors maybe, you're going to learn about 5 new techniques. Not that they're all difficult, but you're going to have all the AB ones. Then you're going to have by parts, then you're going to have improper, and then you're going to have partial fraction decomp. There's just all these other methods, so you need to know what triggers what. Use subs first all the time you try it, and it works half the time. When it doesn't, you default. When you see algebraic paired with exponential, by parts is probably your guy. Who gets to be my u when those two are battling out on the Liate hierarchy? X. Yep. So my dv, go right down on the diagonal, would be the e to the x dx, the rest of it. Then you derivate going down. What's du? 1, yep, 1 dx. And what's the antiderivative of e to the x? All right, so now I'm going to ask you what I said last hour, because on one of yours, I'm just going to wait on this problem. Suppose your dv was e to the 3x, because it's going to be, not 3x, but what would your v have been? Ooh, somebody else say it besides Carissa. Last hour they said 3e to the 3x, and I said be careful. You guys are shaking your head, right? I said be careful because this is an antiderivative. So you have, it's actually USA, but you should do it in your head. you would say, well, it's e to the 3x, but if I took this guy's derivative, I'd have an extra 3, so I better correct it. I mean, that's a good way to think about it. So watch your fraction corrections. There's one in delta math where your dv ends up being like the sine of, I think it's, I don't remember. I'm just going to say 6x plus 1, just put it in there. What's its antiderivative? And you have to be careful. You should be able to think it out, but you should have to think carefully so you don't make, there'll be a 1/6 to correct the, and then what else? Negative cosine, yeah. So good. You're going to just have to watch that you derivate this way, but you integrate this way. So now when I set that up, I'll say x e to the x dx is equal to uv, is x e to the x, minus the integral of v to u. And now it's easy. That's why they call it by parts, because you break it into parts, and now it's easier. What's the antiderivative of e to the x? E to the x. Now suppose, delta math is kind of, I love it, but you can avoid getting the red check, or x I mean, if it's easy for you to check. How do you check your antiderivative? Take its derivative. Yeah, if it's messy, I wouldn't bother, but on this one, I think I just run a little check on it, but it'll work. I'm not going to do the definite integral. We'll save that for another time or even next year. So now let's go kind of roll through this guy. See how we do. We're going to say, algebraic, natural log. This is definitely a candidate for by parts because I have a product of incompatible functions. Let's see if we can roll a little faster and be a little louder. Who's you? Ln x, yes. I want to tell you why. Next year I'll be talking, because this isn't really Calc 1 content. But do you see how it's not that difficult? It's just kind of more. It actually gets more fun, I think. But it would be tricky. I mean, you leave that there. But do you see what the problem is if I let dv be the natural log of x? Have we ever had the antiderivative of the natural log? You know this, guys, is the natural log, but we've never done the derivative of what gives you the natural. It's coming next. There is one, but you've never had it before. The reason natural log gets to be the king is because you need by parts to get it. So it would be silly. It's circular reasoning, right? So we're going to go over here. You should know du, right? What's du going to be? 1 over x, yep. And my v was the x squared. Be careful because you are doing an antiderivative. So I'm going to say 2x. What is it? There we go. X cubed thirds, right? So when I do this, it's going to equal uv of minus v to u's integral. So it will be uv, but I'm going to write it so that it's a little cleaner. If you don't mind. There's my u times v written nicely. Minus the integral of, and when I multiply those, an x is going to cancel. So I'm going to cancel that in my head if you don't mind. When I have these two, I'm going to end up with an x squared over 3, right? And I'm going to put the 1/3 out front. You should be fine with me skipping those steps. All right, so then what's the antiderivative of x squared? It's x cubed over 3, but I already had a 3. And it's done except for what minor detail? Just make sure you're watching. What'd you say? Carl, yeah, Ashley, plus c. All right, 2 more and we're done. So over here, I'm integrating the natural log of x. I forgot the dx. Go put that on there. BC has this one memorized because doesn't it look like a simple function? It is, and it pops up not a lot, not as much as like this guy right here that you guys have memorized, but enough where they kind of got sick of deriving it and they eventually just commit it to memory. So I know it by heart because we did it so much this year. Next year, the first time I do it, I'm going to forget and I'll probably have to run a by parts on it again. but it's x ln x minus x plus c. But every year I debate is a plus or minus, and this is what I do, because I don't use it enough to have it memorized super long term. I don't see two functions up there, but I'm gonna tell you there are, because what did I say the other one is? 1. Okay? Now, it would be really silly for me to do this. Do you get the silliness of it? Kristen, you're nodding your head, right? Why is that so silly for me to let the dv be the natural log? I would have to integrate it, right, to get v, and that's the original problem. So that's silly. And that's why natural log never is the dv. It's always, if it's in there, the very first thing you would let be u, because it's the ugliest one to integrate. So then my dv is the rest of the integrand, which is algebraic. You guys already told me you knew that was 1 over x, so I like that. And what's the antiderivative of 1? X. Done. So now when I run my UVDA, my uv minus bdu's integral, I will get x ln x minus the integral of, the x's are going to cancel, 1 dx. And what's the antiderivative of 1? X. Yeah, that's why I said it's x ln x minus x plus c. How'd it go? I'm going to have you guys try one on your own. And then we have one more. So just on the bottom of this sheet of paper, I'm going to throw 2 incompatible functions at you. I'm going to have you integrate x squared sine x dx. I just made it up, so. Try not to look up here unless you get stuck. I'm gonna slowly do it. Funny. I heard your papers flipping back, and I made this up off the top of my head, but isn't this the one I did? Is that why you guys were flipping it back? I suppose, technically this one would be a by parts twice, right? But we already did that one. I did not intend for that to happen. I didn't even intend for it to be twice. That was just the gods of math being in our favor. Right? Do you remember what we got for that though? Was it x sine x plus cosine? We did it on the previous page, right? So x sine x plus cosine x, I believe, and then plus c. I didn't mean for that to happen. I just took an algebraic and a trig and threw them together. It ended up being you needed it twice, so let's forget that didn't happen and go to the last one. All right. I don't know why this won't turn for me. Oh, I think I know. There we go. All right, the last one. This, I think I mentioned it in this class yesterday because I said if one of them we were going to do with washers, we ended up with the square root of arc sine of x being our r, but then you had to square it. So I said, you don't know the antiderivative of this anyway, so you're forced to use shells. And I think I said, either in this class or the other one, I said, well, you'll know the model. So here's how we figure this guy out. Who do you think the other function is in here? 1. Yeah, perfect. Boom. So now I have u being and dv being. you should see the silliness of letting dv be arctan. It has to be the 1dx. U has to be arctan x. You're gonna see how good your memories are after 3 weeks of not doing much calculus. Are you ready? I'm wondering if you remember what the derivative of arctan is. Do you remember? 1 over 1 plus. It's actually u squared, but in this case u is x, so x squared, correct? Good. Now, you have that memorized, and I told you a little helps for that. I said it's the prettier one because it's tan, and it's nicer in 2 ways, but do you know why it's 1 over 1 plus x squared? I think now would be a good time to show you, because some of you are at a level where you should really understand the whys. Like I could tell last hour, I was looking out, and the ones who understood, I could kind of see it in their eyes, like, oh, that's why it's 1 over 1 plus x squared. So I'm going to go off to the side. If you're not interested, just nod and smile. But some of you should, especially, you should be interested in why that is what it is, not just because your teacher told you x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, why the hell's that? Right? Do you know why? Maybe some of you do. It's actually algebra 2 that gets it, but I don't know if you've ever been shown it. So I'm going to let y be this thing that I'm trying to find the derivative of. Because remember, I'm going to show you why this works. Correct? I don't know the derivative of arctan, but I know how to get rid of it. How do you undo arctan? Tan. If I take the tangent of both sides, its inverse function, I will undo it. Okay? So I took one that this is often how math works. That's why I love it. If you don't know something, you turn it into something you do know unless you break a law, which I didn't, right? Now I do know the derivative. So watch over here. I do know the derivative. I'm going to use the formal notation of tangent because I've learned that before. What's the derivative of tangent? Secant squared. And again, maybe Hannah's going, but why is the derivative of tangent secant squared? Do you guys know why? Or just because I told you? Tangent sine, right, over cosine. What rule do we use on quotients? Quotient rule. If I ran it on this, quotient rule on this, I'll get this. That's why. All right. Now, what's the derivative? Be careful. I almost did something naughty. What'd you say, sweetie? Yeah. This is times y prime equals, and the derivative of x is 1. That's where this is coming from. All right? Remember, I want to figure out the derivative of y. So my y prime is equal to 1 over secant squared y. So far, that certainly doesn't look like this. But watch. But watch, Jonathan. Right? Because I think you'll understand this. Because you like cool math. So do other people. I'm just picking on you because I feel like it. There's my angle y, right? Its tangent is x, technically x over 1. So on its right triangle, wouldn't that be the setup? Correct? Jonathan, what would the hypotenuse be of my right triangle?
Square root x squared plus 1.
That's interesting. All right. That's where that x squared plus 1's coming from, right? Now, secant is the reciprocal of which function? Cosine, correct? The cosine of this is adjacent over hypotenuse. So the secant would have to have been hypotenuse over adjacent. Would you agree? And I just square it. You see why it's 1 over 1 plus x squared? If you don't, just make me feel good. Do it. Non-smile. Yes! Makes me feel like I didn't waste 5 minutes of my life that I'm never going to get back again. Oh, okay. So that's why in red. But you remembered it, so you don't really need to know why, but it's still good stuff to know. So here I go. I'm going to be doing my UV, so my x arctan x. You should understand why I put the x out front. Who wants to say arctan xx? That feels weird. Bless you! Minus v d u. Okay. I broke it into parts, of which I'm supposed to know how to integrate, whoopsie, that second part. I'm just going to leave it right there. Just trying to grab my highlighter. I forgot I unactivated it. I'm supposed to know how to integrate this, and you should. What am I gonna use? Who said you sub? I heard it. Okay, you whispered it. Have confidence. Say you sub! Although, did I tell you about the kid who did that one year? And that is on his senior shirt. You know how you guys have your nicknames on your senior shirt? His was Yusuf because he yelled it out in an implicit differentiation problem. I said, you guys, what is this screaming? And it was screaming implicit. Yusuf! I'm like, no! Everybody started to laugh and then kids were like, hey, Yusuf, what'd you get for dinner? And then it stuck and then he put it on his senior shirt. Alright, anyway, his name was Ben. I don't remember what his last name was. Do you guys know? Verdict. Ben Verdict. Have you ever heard of him? No? That was like 3 years ago. But there is a little guy named Ben who on the back of his senior shirt it said capital letters Yusuf. Alright, but you were correct, Avery, so say it with gusto. What do I use here?
So,
No, I'm not fine. Come on now. What do I use here?
your sub.
Are you sick?
No. Yeah. Kinda.
I need you to yell it. What do you use?
Your sub.
Yes. That was really weak, but I'll take it. Alright, my u is, you guys are killing me. My u is 1 plus x squared. Why does it work? Because my du is what? 2x dx. I want it to be x dx, so there I go. I'm really just sitting there with this situation. X arctan of x minus the integral of u. All of this crud is 1/2 of du. Avery, what's the antiderivative of 1 over u?
One for you?
What's its antiderivative? Until you say it with gusto.
What?
Don't say implicit differentiation! No. What's the antiderivative of 1 over u to u?
That's so
That's
wrong.
somewhat, he was asleep 5 minutes ago, so
Yep.
don't think it's so great, but, alright. Thank you, Pumpkin. So I
Welcome
have x, arctan of x minus, and he said, natural log, he even remembered the absolute value, which last hour they didn't, but I said, I'm gonna let you get away with it. Why did I tell them I would let them get away with forgetting the absolute value on this one?
It's gonna be positive.
The argument of the natural log, what I mean by the argument is this stuff is always positive regardless, so it wouldn't mathematically matter, but I'm so proud of you for remembering. So if yesterday I said, guys, I want you to figure out the antiderivative of arctan of x, you'd be going, some of you would have done this. Oh, that's the pretty one. You know you would have, right? That's its derivative, not its antiderivative. I don't think anybody, except maybe Tristan B, would have said, it's x arctan x minus 1/2 the natural log, the absolute value of 1 plus x squared plus c. Thank you very much. Wouldn't you have? Yeah, I think so. Have confidence, more than Avery does. You sub! Alright, we're done. So, you're gonna go to Dotama. There are 4 of them. Yes. I programmed it to give you all the same ones so you can work together. I also programmed it to see an example if needed. Because I didn't do a ton of them. Next year we'll take care of that.
Can you put this in as test points?
No.
Please?
No Greg Grubbin. Oh, I gotta.
It's really easy. I'll set up a nice little process.